After thinking about how I would test the Pam8403, I ended up building a internet radio inside the old radio. The case and speaker are from the original radio. I added small LCD, 4 buttons for presets, volume knob, and a on-off switch. Flipping the switch to on position, the LCD's backlight will turn on and the music will start playing. I can't play the music the radio is playing because of the copyright issues, so I won't take a risk playing it. But here's a sample of music that is royalty free that I can actually use in this video. As long as you are in the same room as the speaker, the Pam8403 has enough output power for pleasant listening volumes. Next I'll give you some kind of overview of this internet radio, including simplified block diagrams of the hardware and software. The supply power comes through this 2.1mm jack, and the supply voltage can be quite a wide range of voltages because this radio has LM2596 module, which will regulate the voltage down to 5 volts, which combined with the Raspberry Pi's 3.3 volt regulator will be enough for powering all the circuits inside this radio. This add-on board includes the filters that Raspberry Pi Zero doesn't have. They make the PWM output into a nice analog signal, which is then connected to the potentiometer, which acts as volume control, and the output from the potentiometer goes to Pam8403 amplifier, which drives the speaker. This is a block diagram of the hardware. The switches of the front panel connect to MCP23017's port B, and the LCD is connected to the port A. The MCP chip has been connected to the Raspberry Pi through the I2C bus and one GPIO, which will read the interrupt from the MCP chip. The audio comes out as PWM, which is going through the filter that has been left out from the Raspberry Pi Zero. It is available on other Raspberry Pis, but for Zero it has to be added externally. But luckily it's just a couple of resistors and a couple of capacitors, so making one is easy and cheap. I made an analog volume control with just a potentiometer, input going to the one end, ground to one end, and output will be taken out from the Viper. Both the filter and potentiometer need to be added for both channels when using stereo amplifier, but as I only have one speaker on this radio, I will combine the outputs with a summing circuit which is made out of 2 resistors. The mono signal will then be connected to amp's racked input and output will be taken from racked output. I'm using MPD software for playing the actual music and the MPC for controlling the MPD while configuring the radio. I added local radio stations online streams to MPD's playlist using the MPC's add command. The Python script will use MPD client class instead of the MPC to control the MPD player. When user clicks a button, MCP chip will send interrupt to Raspberry Pi's GPIO and the Python script will read the input using SMBus class and send the appropriate command to MPD. At the moment the whole project is in proof of concept state including the software, so at the moment I'm not going to publish the source code. But I might make part 2 video and clean up the source code for publishing.